Hi everyone. I hope I'm audible. Yeah, I think I am. Yeah. Let's just wait for like 1 or 2 more minutes and then we'll get started. Good evening, everyone. Um, so, um, Welcome to the live interactive session of NPTEL ACN. So, I believe all of you would have taken this course, NPTEL ACN, and not sure if all of you would go through with it and go till the examination. Some of you might hang around, some of you might not. But essentially, I would like to give you an overview of what is the objective of these extra sessions that we take, and how possibly you can use it to enhance your understanding of what you're studying in this course. Right. So, advanced computer networks. So the name itself suggests that it is advanced computer networks, which means that we assume some level of knowledge for all of you in computer networks, right? But although I as a former BTech student, I understand that computer networks would have been a course which most of you might not have liked or might not have understood properly, right? So the objective of this live interactive session is geared towards folks who um, need a refresher on computer networks so that they can be ready for taking up the advanced computer networks course. And my name is Harish. I'm a PMRF PhD student at IIT Hyderabad, and I think I will be the one to interact with you every week starting from now for the next 12 weeks. Right. Um, every week on Tuesday evening, 7 o'clock to 9 o'clock, I'll be there online, and we'll be discussing the topics that were taught in the previous week. Right. So, what will be the structure of our classes, or rather our interactive sessions. So what will be the structure of our interactive sessions? So it will involve us solving around 10 to 20 questions. Okay, so this is the official mandate that we have to fulfill, in the sense that we need to solve the questions associated with the teachings of the previous week, so that you can be empowered enough to take on the exams at the end of this course. But although this is the main objective, I would also like to, for the first one or two such interactive sessions, I also would like to talk about computer networks from a very, very general standpoint, so that even someone who is not adept with computer networks would be at a place where he can understand computer networks, and then would be at a place to tackle the questions or the syllabus being taught in this course, right? So the secondary objective of these courses were to give the basic knowledge of computer networks, right? Although 2 hours is not enough for this. 2 hours is definitely not enough for this. So I'll try my level best to give a primer and then just move forward. So the only way we can make this work, right, is for those people. So the only way we can make this work is for those people to uh, come out and ask questions, right? So if you don't understand something, so you need to either put your questions in the chat window, or you can just unmute your mic and speak. So please ask questions. To make use of these sessions. So as of course, as I already told, this is basically an interactive session. So the more interactive that this becomes, the more useful that it might be for you. Okay. Right. And again, when it comes to asking questions, do not worry about the fact that you are asking some basic question. No question is a bad question, and I actually mean it. Uh, you can go ahead, and I'm repeating this again. You can go ahead. You can ask even the most basic of the questions, and if I know the answer, I'll tell you. If I don't know the answer, I will catch up to you, and I'll tell you in the next class. Right. So this is more of an interactive session where we try to make it a two-way learning platform, where I, of course, tell you what I know, and if somebody knows something better, or if they dispute with what I'm saying, they're free to come out and they're free to tell me that this is wrong. This is why I think this is the right answer, right? So let's keep it like that, because yeah, right. So final exam is registration is okay. Let's just get so you can just put all of the questions in the chat window. We'll get to it one by one, right? Yeah, so questions, right? This is a very, very important part of this. And if you can always just type whatever you want in the meeting chat window. You can say hi to folks. I mean, it's a fun place, right? You can just do whatever you want, right? And then now coming to the course logistics. So I don't know how many of you are taking PMRF, the NPTEL courses for the first time. So this course is NOC 25 under, this is the course code CS02, right? Okay, okay. Nice. I'm already seeing questions. So I'm sure some of, yeah, please, you can just go ahead and unmute your mic. And if you're not able to unmute your mic, let me know. I can give you that option. Kirubavati, yeah, right. right? Is that Kirbavati? Yeah, it's Kirbavati. You can just unmute a mic and speak, or you can put your question right. Okay, so there is a question being asked. Harshita Jadhav. Sir, is final exam registration necessary for certification? Yes. Uh, Registration is necessary for your exam certificate. Right. Okay. Okay. So how many questions will come from the problem side? All right. Okay. So how many questions will come from the problem side? So when you mean you say problem side, I'm assuming you're talking about the calculations, right? Numericals, as they would call it in your. I'm just taking some pauses in between. Apologies for that because I have to admit people inside the chat. I think once I've admitted people, you can join next time completely. Right. Okay. Nice. I'm seeing a lot of questions. Let's talk logistics for the first maybe half an hour or 45 minutes, and then slowly we'll ease into the subject. We have 12 weeks, so we can slowly go over things. The second question is how many questions will come from the problem side of things, which is basically numericals, right? Where you have to calculate things and we'll have to answer. So advanced computer networks, this course definitely has a good amount of numericals. Right. So you can, I think, expect around 30 to 40 percentage of numericals, but don't hold my words on that because it always depends on the final exam question paper setter. So, but the place from where you can get a hint of what you can expect in the last exam is by solving your assignment questions, right? So, which I think must be already live for you folks. So, assignment questions of the current week. Okay. So this is one place where you can see the distribution between normal theory questions and numerical questions, and the almost, let's say, 15 to 20 questions that I will be discussing. Right. So these two will probably make up around 30 questions, let's say, every week. So I think if you can tackle these questions, then you'll be at a good place to uh,
Hello, sir.
oh yeah. Hi, Kavita. Yes, hi. Please go
Hi,
ahead.
sir. Sir, I have one doubt.
Sure, please.
Sir, if classes are coming, I listened. Then how to send assessment to you, sir? Throwing
Oh,
mail. Uh,
okay. You are asking me how to give me the assignment questions,
uh,
or
Sir, this is objective types or theoretical types, sir?
just 1 second. I think there is some disturbance. Just give me a moment. Uh, yeah. Okay. I mean, so again, let me rephrase your question. Um, so you're asking me how can you attend the classes when you're having classes, right? Is that a question?
I attend the class.
Mm-hmm.
You are sending mail message, no, sir. I
Right.
see on
Uh-huh.
which day his class is there, I can attend, sir. So what is my doubt? No,
Mm-hmm.
you can tell the lessons and classes. Then you ask no assessment, sir. I prepared and how to send to you, sir. I don't know. That's why I'm asking, sir.
Okay. you want to send to me assignment. I mean, apologies to everybody else in the class, but I think I can understand Kavita better if I probably speak in her own language. Kavita, are you from Tamil Nadu?
Sir, huh?
Are you comfortable with Hindi or Tamil? I can speak in those two languages as well.
No, sir, I only talk with Telugu or English, sir.
Okay, fine. Okay, I don't know Telugu, so again, to just understand what you're trying to say. You want to send me assignment questions?
Ah, yes, sir. You completed week one, no, sir. You,
Correct.
on February 5th is last date to send the assessment, no, sir.
Oh, okay. I
No,
see.
sir,
You want
that's
to
He
why
is
I'm
answer.
asking
asking.
about
Okay.
how to answer the assignments.
Oh yeah, right.
How
Ah,
to
So,
yes,
use
sir. How?
Kavita,
assignments and how could you send to the assignments in particular way they are asking, sir.
Ah, yes.
okay. I got the question. Thanks, guys. Thanks for clarifying it. So basically, you're asking me how do you submit your assignment answers, right? So that is very simple. And if anybody knows a better answer than this, then please go ahead and unmute and speak. So you have the NPTEL website, right? Where you can go and see the
Ah,
assignment. Correct.
okay. Ah,
There you have 10 questions, and then for all the 10 questions, you can choose answers. Correct.
sir, you only send the 10 questions, sir.
Those questions are not mine. By the way, I'm not Professor Hubali or I'm not any of those professors. Okay? I'm a PhD student, by the way. I'm not one of those professors who's going to set the questions. So it is they who do it. I'm just a
Sir,
student who is, yeah.
send on mail only, na, sir.
Uh,
No, along with this class, I'll just let me clarify. Every week you are going to listen all the videos which are
Ah,
there
yes,
in
sir.
the NPTEL website. At the end of this week, you will have an assignment questions. You need to answer for that. This is a live session, doubt session. Here need not necessary to submit any assignment. This is the thing,
yeah, right.
right?
Ah,
Okay.
okay. Okay, sir.
Uh, Thanks, brother. I mean, yeah, that's good. So you don't have to send anything here. And just going along with that question. So all these weekly sessions will be recorded and it'll be put on YouTube. So you don't necessarily have to attend the sessions if you are busy. You can always rewatch them on YouTube because all the questions will be solved in these assignment sessions. Right. So let's go back to the
Where do
questions
you post
and
that YouTube link, sir?
yeah, right. So they will be soon sending you a message with a sheet, with a Excel sheet with the links, the relevant links. So two things will be there in that sheet. So what will be there is the YouTube link, and second would be the presentation, or rather whatever I'm writing right now. Correct. So as a PDF. So these two you'll get it so that you can revise at your own pace.
Okay, sir. Thank you. Yeah.
Right. So again, just to clarify what Kavita was asking, she assumed that we had to submit the assignment to me, but that's not the case. You have to submit it to the interface itself. You have to go there, you have to choose the answers, and you have to press submit, and that's pretty much it. But you have to do it before your deadline, correct? And that will be visible on your interface. So we are talking logistics right now. Mm, right. So YouTube content is enough to pass. So overall, yes. Again, uh, I mean, if your intention is to pass the exam and get a certification, yes, I think that should be more or less sufficient. You can get decent marks, but it's better if you don't look at it as just reading reading some materials and trying to answer questions just to get your certification. Better you look at this as an opportunity to learn, and because if you read it from an exam point of view, you might probably not appreciate the subject, or you might probably forget it in let's say the next 3 months, and the only thing you'll have in your hand is your certification. So again, if you're planning to build up on this knowledge and do something further, then exam, yes, of course, you have to handle the exam, but try to understand the concepts which are beautifully taught in the main lectures. And if you have any questions in those concepts, you can ask them to me. And if I know them, I'll tell you right away. If I don't know them, I'll definitely catch up to you on the next session and I'll give you the answers to those. Right. So let's look at this as opportunity to become better in computer networks rather than just trying to pass. Of course, I'm not saying answering questions are not going to help. It's definitely going to help you understand it better, but uh, try to have a more broader viewpoint than just trying to pass your exam, right? So that'll definitely be a better aim or a better standpoint to understand or go through this course. Right? Also, the other person, Dhruv, is asking. Right now, I'm pursuing my CCNA, which is Cisco Certified Networking, right? CCNA, and I wanted to know more about networks. So basic knowledge of computer networks in CCNA, I opted for this. So can it? So will it help in my future journey of networks? Oh, definitely, I think it will, because I'll also give you a brief overview of what we might be going through in the next 12 weeks, and definitely this course will put you at a place where you can see what is happening in networks right now. Okay. So all that we know in networks so far is the different layers of networks, and then you see how things happen from a very high level perspective. Correct. So, but what are the current advancements in networks? What are the current research challenges in networks? So these are things that you'll be introduced to in this uh, course, right? So definitely this would help you. But since you are already pursuing your CCNA, which means you must be pretty good with your basic networks. Some of the initial classes might not help you because this is just a rehash of what you might have already learned. So all of those, for all of those people who already are good with networks, you can probably skip the first few classes, so that you might probably get bored because I'll talk about a lot of generic stuff once again, just to uplift the folks who are not adept with networks. That is the objective for the first few classes. Okay, so with these, I think we can probably get in to the questions this time. Um, yeah, and any more questions if you have, you can put it on the chat window. Right. Okay. Right. I think the audience here must be from a varied demographic. Some of you might have just finished your bachelor's. Some of you might be pursuing your bachelor's. Some of you might be masters. Some of you might be working somewhere, and very difficult to address different levels of knowledge. So we'll just have a small overview of computer networks, right? And then from this overview, let's go into what was focused on in week 1. And then we'll discuss what is to come in the coming weeks. Okay, so computer networks, all of you, I think the one thing that all of you might have studied is these layers. depending upon which book you study, you have either 7 layers or you have 5 layers, correct? So let's go with the 5-layer approach. So you have physical layer, and then you have data link layer, and then you have network layer, and then you have transport layer, and then you have application layer. Right. So as students who are introduced to computer networks for the very first time, most of us, what we do, okay, fine, there are layers, and these layers communicate with each other, and then it just happens. So putting this into context of how current networks work is a very important aspect, so that you can appreciate how the world works. Because you have to understand that the internet that you see today works because of the concepts of computer networks. Every time you pick up your phone, or every time you type youtube.com, right, it's because of the way computer networks were built and the way they're operating. So it's something that works in the current world. So how do you understand how something this complex that and the way it works, right? So for that, we can put certain things in the context, and let us okay, I see a question. Once again, tell about these. Yeah, we'll come to that. Sure, we'll come to that. I think I should be able to change a setting where everybody can join without me trying to admit them. But yeah, let me just give me a moment. I'm just trying to change some settings. Just give me a moment. Right, everyone. I think now you can leave and join whenever you want. I don't think I need to admit everybody individually. Okay. So some more details about the layers, right? Yeah, we'll come to that. Okay, so and there is, yeah, of course, is the OSI model. Let's not go into that right now. Let's just stick to this because 5 is easier to understand than 7. Right. So let's take a practical example, and then let us see what are all the components involved in computer networks, and then let's zoom into these components, right? So let's say this is you, and you have your phone or you have your laptop, right? And then you have your Wi-Fi access point, correct? I think everybody must be having a Wi-Fi access point. And then one fine day you decide to go on your phone or your laptop, and then you say, I want to go to youtube.com, right? So what happens here? Your Wi-Fi router has a connection, right? So you plug in a cable into this. You plug in a cable into the Wi-Fi router, and then you say you have internet and you're able to communicate. So what happens behind this scene here? So your Wi-Fi router is connected to, let's say, a network, correct? Through other routers. and this is basically your ISP. Okay. So from here, from this ISP, you have a bigger cloud, or rather a bigger network, correct? Which is once again connected by routers. And then finally, you have Google data centers. Okay. So the moment you type youtube.com and then you press enter, so you are giving some instructions, right? So you are telling your computer to go and fetch youtube.com. Correct. So this is pretty much what you're doing. And again, I'm telling you, I'm giving you the absolute basics of computer networks as to how things work. So feel free to leave. There is no uh, it's not like you have to attend this class to get marks. There's nothing like that. So you can always feel free to use your time the best way that you want to use your time. All right. Uh, Again, the first few classes would be very basic, so please let's just you can just bear with that. The folks who are already adept at this, right? So again, let's come back to this. So you ask for youtube.com. So essentially in your computer you try to fetch it. Like what do? You go to your browser and then you type youtube.com and then you press enter. So what happens behind the scene? So your computer converts this request, right, into something called packets, correct? So what are these packets and all these things? We'll come to that later. So essentially your message, okay, please give me youtube.com, is converted into packets. And what do these packets contain? What are these? These are basically just bits and bytes. In the sense, whatever you typed as characters get converted into bits and bytes, and they are sent in the form of packets. Right? So these packets, they first go to your router, sorry, to your Wi-Fi access point. So what does your Wi-Fi access point do? Your Wi-Fi access point, it sends these packets further to the next, what is this, router. So from this point onwards, these packets that you send contain some information. Right? These packets contain information. They contain some kind of information which will help them reach this point. Correct, because it has to reach here, right? Because this is where your youtube.com is. It somehow has to reach youtube.com. Correct. So what is this information that these packets contain? Anybody has answers to this? You can type it in the chat window. What is that unique information that these packets contain, which help you, which help the packet reach from you to the server?
Is it IP address?
Yeah, you're right. Exactly. So this is IP
Source
address.
IP and destination IP.
Exactly. Exactly. Perfect. So, so the unique information that it contains is called an IP address. So again, what is an IP address? An IP address is an address. So it's like every house you have on the street, every data center or every server that is there on the internet has an IP address. So this Google data center, let's say, has an IP address of, okay. So Mir Ishfaq has said MAC address and IP address. Right. So IP address is the correct answer. MAC address is a bit of a local address. We'll come to that a bit later. So the answer to this is IP address. I don't want to confuse the MAC address right now, but yeah, MAC address is also used to identify devices, right? But not at this scale, at a smaller scale. So coming back, so an IP address, and what does an IP address look like? It's got something like 192.168.0.1, let's say. Although this is not a public IP address, so so this is an example IP address. Correct. So let's assume that the Google data center has an IP address of 123.12.13.4. Okay. So this is the address that these packets have to go to. So now, when you fetch YouTube, what do you have to do? You have to put the destination IP address as what do you have to put it as? You can put it on the chat window. So every packet that you send should have a destination IP address of what?
Server IP address.
Yeah. So what is the server IP address here?
123.12.13.1.
Perfect. Yes. Good. 123.12.13.4. Right. Yeah. So each and every one of these packets, right? They have this information on it. So these packets have the destination IP address as 123.12.13.4. So once the packet leaves your computer, okay, this is the beauty of the network. Once the packet leaves your computer, that you have no control over it. You've sent it. You have basically like putting a postcard on the post box. You write an address and you put it, and somehow magically it goes to the destination person and he's able to read it. Similarly, networks are also built in the same way. The only point where you have control over things is your end. So you have to put every possible information on the packet in such a way that it will reach the destination system or the destination YouTube data center. Let's say youtube.com, right? Data center. And the most key aspect to that is your destination IP address. Right? So you've put the destination IP address and the packet is here. So based on this destination IP address, every single router here, right, that goes in the path will take some decisions. So let's trace what happens. You have these packets, and these packets are in transit, and this router gets a packet, and then this router, it tries to take a decision, and it sends it over to here, right? And then the packet is here, let's say. Now let's say this router has two options. It could send the packet either here or here, correct? Because there are multiple routers that are connected to each other. So, but based on this address, this router might know that, okay, if I send it here, it will reach the destination address. So it sends it here, and then this router once again makes a decision based on what? Based on this IP address. It can probably send it here or here anyway. So the packet is over here, and then this probably sends it over here, and the packet goes over here, and the packet goes over here, and finally reaches youtube.com. And once it reaches, the same mechanism happens, and the return packet also reaches like this, or in another way. Let's say it can go in any way, and you get your videos and everything that you're able to see. So the point that you have to realize here is how much of a distributed system this is, where the moment you've sent a packet onto the internet, it is reaching your destination server, all based on what? Purely based on your IP address only. So how beautiful is that? right? So this is essentially how the internet works in a nutshell, right? But in all of these, so whatever I've shown you right now, what is that key device? What is that key device that enables this communication? What is the key device that enables communication? Look at this picture. What is it that enables this? Yep, perfect.
I
Sean
think
is so
router.
yeah, right. It's the router, Mahesh. Yeah, correct. So what are these routers? These routers are here, here. Routers are here, 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 and also in a way your Wi-Fi access point is also a router, but it's not a pure router. But yeah. So question again: are all routers the same? Are the routers that are present here same as the routers that are present here? The answer is yes or no.
No.
If no, okay. Why no?
Definitely no.
There should be a customized routers must be there, right?
Customized routers, like
According to
mean
web,
route.
there are different routers like core router, edge
Exactly. Yes.
router.
Border router something.
Exactly. Good. Good. Correct. Perfect. So all routers are not equal. Again, there is discrimination in the form of routers. Let's say, right? So a router that is present at this edge. Okay, I'm circling this one over here. This router or this router has different functionalities compared to this router.
Are they switches also?
Oh yeah. So again, I don't want to confuse you, but in classical definition, a switch is not equal to a router, basically. Right. So let's stick to that. They are not switches. They are routers.
Okay.
Right. But again, to answer your question correctly, at this point, the word switches are interchangeably used for routers since the advent of programmable data planes, let's say. So in a way, the definitions have changed. So traditionally, switches were dumb, are supposed to be dumb. Routers are intelligent. And we'll see all of that. But I think for the purposes of this course, um, at least for the first few lectures, you can assume these are routers and not switches.
Okay.
We'll see intelligent switches, which are also called routers, I think around the 6th or 7th class or 8th class, I think. Yeah. When we get introduced to programmable data planes. Let me write that also so that when you read that or when you come to that, you'll programmable data planes. Right. So this is advanced. So let's look at it later. Right. But again, that's a good question actually. There is no straightforward answer to your question again, because I'm confused about it as well. Right. So are all the routers same? No, we are discriminating. We are discriminating with against routers. So we have some routers which are the edge. These are called the border routers, and some of them are core routers. In the class lecture that most of you would have seen probably, it was clearly mentioned what these routers are and when what and just and what it is that they do on a on a general level. But let's not go into that right now. You can always go back and watch your class lectures. So the point here is these are all routers, right? And these routers are the key enablers of communication. So the lectures of class one of week one purely concentrated on routers and how they handle packets. So week one was all about routing and how it routers. Okay, let's say routers. Routers and their functions, right? So yeah, so this is the overall view of basically how the internet works right now. But then now the question is, where do these layers apply? I mean, now what is the now that I've told you that okay, it is being cut into packets and it is being sent and it is being received back. All that is good. But then why did I talk about these 5 layers? What is the connection between these two? Um, I'm putting the open question. So would you like anybody can unmute and give me their views on how are these two things related even, or where does this layers fit in this diagram?
Is it in the network layer?
Yes, it is in the network layer. Again, right. So your IP address is in the network layer. But my question was on a more broader scale. So I've told you that your communication goes through these routers, right? But then why these 5 layers, and where do these 5 layers apply to in this diagram? Do they apply to the router? Do they apply to the packets? Or do they apply to the server? Or where do they fit in? So I'm asking these questions to gauge how much you have understood computer networks versus was it just studied and uh, just for the sake of exams, right? So just to give you that context is why I'm asking these questions. Is ISP transport
I think in
layer?
PC.
Oh yeah, okay, good. We're getting close. You're saying in PC, in the computer, right? So in PC, personal computer, in PC. In the sense, you're saying these layers apply here, correct? Okay. So let's come to that. But no, ISP is not transport layer. ISP is internet service provider. Okay.
The data
Okay.
changes in every part of the layer.
Right. Correct. You're close.
Means data remains the same, but it changes its type.
Okay. You're there. You're almost there.
Means on data in physical layer, it transfer in frames and it changes in every layer.
Correct. Correct. Your core data does not change, but you add some more layers onto the data that you want to send. And I think that's what changes as what you're trying to say. But again, let me give you the answer to the question that I just asked. If anybody else wants to give it a shot, you can give it a shot.
So it starts from the application, and then in the same like your PC you have these layers, right? So from
Mm-hmm.
application it goes down to the transport. Some things
Good.
headers are added, I guess. From then it goes
Mm-hmm.
into the network again. There, source destination IP address is added there. Then the
Mm-hmm.
data link, and in the end physical layer is your bits and bytes, I guess. And then it
Mm-hmm.
gets
Yep.
transferred across And then again the reverse happens from the bits and bytes to data, and then to the network, and then transport and application. I think the reverse
Perfect.
happens at the other end, right?
Exactly. Yes. You've perfectly said it out. But yeah, I mean, Anuradha has given us the exact answer. But let me just draw it out so that everybody can understand what she just said. So again, in PC, so all of you have given some bits and bytes, some bits and pieces of the answer. So let me just formalize all of them. You see this diagram? I'm just simplifying this diagram downstairs so that we can understand things better. Okay, so this is your PC, and then this is, let's say, one router, and then this is your data center, right? Okay, I've just simplified the diagram. That's all. There's nothing. So this will apply to every other router also. So now you want to ask for youtube.com, correct? So this is your data or your payload. Okay, so this is your payload or data. This is youtube.com in the sense that this is what you want to request and you want to send. I'm just giving you a very simple example here. This is not exactly how it is. It's a lot more, slightly more complicated than this. But this is a message that you want to send, or you can even say message. Previously, I told you it goes in the form of packets like this, correct? But I never told you what is inside these packets or how these packets are generated. Now we'll look at how these packets are generated. But your computer, it has something called the network stack. Okay. Now your computer's network stack is a part of your operating system. Okay, this is not important, but just understand that this is a network stack. So what it does is the moment that you want to send something over the internet, it will take that data, that payload data. Okay, so let's say this is the payload data. I'm denoting it by, let's say, this box, right? So this is exactly your payload data, this one, correct? So what it will do is it will take this payload data and then it will add layers onto it. Right? First, it will add a layer called application layer. Correct? After that, it will add the transport layer. And similarly, as we go down, application, transport, network layer, right? And then the remaining two layers, the data link layer and the physical layer will also get added on. So I'm not drawing all of that. So 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Yeah, right. So by the time you press enter, your original data was how much? It was just this much. Just youtube.com. That's what your data was. But then by the time this data goes down and then goes into the wire, you have all of these layers being added on. So if you want to send, let's say, 1 byte of data, your data doesn't remain at 1 byte. You definitely, your core data is 1 byte. This part is 1 byte, but then you get so much more bytes added on. Like you have to add 48 more bytes. It's just an example. Plus this to even send it. So what are these extra bytes? So these extra bytes are extra information that you add on to the payload or whatever you want to send, so that the devices in between or the internet devices can understand where you're trying to send it and send it properly to the destination. Right. So among all of these layers, one of the most important layers is the network layer. And the other one is the transport layer.
Network layer.
Yeah, network layer, right? You said network layer, correct? And Anuradha also just now said that the network layer is pretty, I think someone was saying, I'm not sure. So the network layer and transport layer, these are quite important. I think you would have read all of these in your basic computer networks course. So you can try and correlate with all of that. So what are these layers? These layers are just a way in which humans, we designed the computers, we designed computer networks. So we thought it'll be easy if we separate these layers based on their functionality and add those information at different layers so that everybody can understand. So let me again rephrase that. So here in your source over here, you are adding layers like this, right? First you're adding application, and then transport, and then network, and then physical, and then so data link, and then physical, right? That's pretty much how you have it. Now every packet that you have here, right? Every packet that you send has all of these layers. Okay? What is the first big point? Every packet or every chunk, let's call it packet, has all of these layers. Every packet has all of these layers. So let's assume this packet is reaching over here to this router. Correct. So what will be there? Have this first layer, second, third, fourth, fifth. Correct. So all these layers are there. Correct. So now this router device, it has multiple options. Correct. It can either look at the physical layer, or it can also look at the data link layer, or it can also look at the network layer, or it may be able to look at the transport layer, or it might want to look into the application layer, or it might want to look into the data itself. Correct. Because we're sending it, the packet we've sent it, we've completely sent it to them. So it depends on the router as to what it wants to do. But because we have layered information like this, because we've told everybody, first I'm going to add application layer data, and then next I'm going to add transport, and then network, and then physical, so and then data link, and then physical. The router knows, okay, what is information that I want in order to put this packet over here? What is the information that I want? I need IP address, correct? It needs IP address. So where is the IP address? Which layer do we add the IP address to? We add it to the network layer. Correct. So the router will go and look into the 1, 2, third network layer, and it will take out the IP address from there. And then based on the IP address, it will forward the packets to the corresponding destination. And just to let you know, routers cannot look beyond the network layer. Okay? So it can only see till the network layer because that's enough. We'll tell no, why is it that these devices cannot have no need to see anywhere beyond it? Because what we need is IP address. IP address is there in the network layer itself. It's the third layer. So it can just look at the IP address and it can go. But more than anything, why do we limit the functionality of these devices with respect to being able to look at all the layers? Because these routers, they have to process so many packets. Correct? Now, it might look trivial, but they are looking at traffic at around scales of Mbps and Gbps. In fact, Gbps scale. So for every packet that comes, you have to get the packet. The router has to get the packet, and then it needs to analyze. Okay, this, and finally get the IP address, and then it has to move on. So every single byte that the router reads is costly. So human engineers have engineered things in such a way that these devices, right, they have to read as less as possible in
So
order
does
to
it have
get.
to, sorry, does it
Uh-huh.
have to unpackage the earlier layers to reach the network layer? Is that how it works?
Um, in fact, it's okay. So, okay, when you say unpackage, right, you can definitely just go and read the layers because it's kind of added on to these layers. We just in the diagram, I have definitely put it as it has been encapsulated, but in reality, it is just added on. It's like stacked on top of each other. So it may not necessarily have to unpackage the first two layers.
Okay,
It can
so
just
directly
it can just directly point to it. But that's actually a good question. Let me just as far as I know, yeah, I mean. So yeah, I think. mm, So the exact implementation of this is something that okay, I'll get back to you on this, right? Like I have to, as far as I understand, although they call it encapsulation, like they encapsulate this with something else. So it's like this. Right? It's basically like you have this data, and then I'm adding this layer on top, adding this layer on top, layer on top, like this. Okay. Now, when I'm reading the data, I know what is the size of this layer. I know what is the size of this layer, this layer, this layer. I know it because that protocol is accepted all through the world. So I just have to ignore these first few bytes. Let's say this is 10 bytes or this is 20 bytes. I just have to go directly to this. This is how I came up with the reasoning that you don't have to basically unpackage anything. You can directly just go and read it.
Like a random access file. You know you have to go to
Yeah,
this position and yeah.
exactly. That's pretty much how I think. But again, I have to confirm this though exactly because again, some cases there are encryptions that tends to that makes that you for which you have to read the previous layers and then decrypt the files later and decrypt that further layers. But yeah, I think as of now we can keep it like this. It's like just directly accessible. Yeah.
Okay.
Okay, well, that's actually interesting. Good question. I thought. Okay, good. Yeah, I'll get the exact answer next time. Okay. Right. So layers. We were at layers, and so yeah. So these are these layers, and why do these layers work? Because everybody has agreed on it. So this is the way things work. Because the understanding of layers at my PC is the same as the understanding of layers at the servers, right? And at the routers. Uh, here here the first layer is let's say 40 bytes. Second layer is 50 bytes. That means the router also knows the first layer is 40 bytes and the second layer is 50 bytes. So it'll know first 40 bytes, okay, it's layer number 5. The next 50 bytes, it's layer number 4. The next 48 bytes, it's layer number 3. So in that sense, it knows which bytes correspond to which layer, right? So this is why it's just to so you can even ask, why are these layers even created? Why can't I add everything into the into one big layer and then send it? Why do I have to put why is there so much complexity? Why can't I just have my payload and then add one huge blob of data which contains IP address, which contains everything? Why can't you do that?
I think you need different services to work on different layers. I think that will kind of give you segregation or coupling, coupling kind of a thing, I guess.
Yeah. So again, we can do this also. I mean, in a world where I want to do this, I can do this also. I can either layer the data and put separate layers like this, or I can just put everything not randomly. I can just put everything together. So this, as Anuradha was saying, it gives separation to different functionalities, right? In the sense, the router only wants to look at network layer, so it will be able to look at the network layer and not look at anything else that it doesn't need. And that is why the layers are also organized. The highest abstraction, which is the application layer, from that layer onwards, we go lower, 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 and then we go to the physical layer. So most of the devices in the middle of the network, let's say these core networks, they don't need data from the application layer. So you don't have to force them to go through all of that data. In the sense, you don't have to tell them to read that also, or at least skip most many number of that much of bytes to get there. So for these reasons, we have whatever we're adding segregated into layers, and these are put, right? So now coming back to our routers, right? So what is the router doing here? There is an ingress. You're getting some data, and then there is an egress. And what is the router reading? It is reading an IP address, correct? So one more. So a router, what is it doing? There is an ingress. So ingress is nothing but input of data. There is an egress, correct? There is the output of data, and it is doing something in between. right? It's doing some functionality in between, which helps put the packet onto the egress interface. Right? So a packet comes like this, then the packet goes into the processing of the router, and then it goes out here. So what happens in this space is what this week spoke about. If you had seen the videos, now you'd be able to understand the context behind why we are looking into routers. So again, just to go back, we saw how the internet worked, or rather how information is sent from point A to point B. And then for this to function, correct, we also have something called layers, and how these layers are instrumental in allowing the devices in between, for example, routers, to read the exact data that they want to read and then send the packet onwards. And then now from this point onwards, we are coming to looking at how these routers function. Correct? And everything in week 1 spoke about this. You can always go and watch the videos again for this week. Now, with this context, if you watch the videos, you might be able to appreciate it a bit better, right? So there is ingress, there is egress, and you have this router, correct? So since we only have like 30 minutes left, I think I should just quickly go through the questions and answers. I might not be able to explain all the questions properly. I'll give you the solutions to it. If you have any questions, you can just ask it in the next class, because there's 30 minutes left. And yes, exactly. So again, I ideally I would have loved to have explained everything that was explained in the video, but that'll be redundant. So I suggest you watch the video to understand how the router works and what is a routing table. Correct. So a router has a routing table like this, right? I mean, I'm just rehashing it from the video here, just a small rehash. So you have IP address 1, let's say xxxx, or let's say 1.2.x x23. These are all IP addresses, and then it has the port in which it has to go. 2, 3, 4. Since let's say it has multiple egress ports, port 1, 2, 3. So the router will know that if the IP address matches this one, then it has to send it on to the egress port 1. Or if it matches to 2, to this one, it has to send it to egress port 2. So this is basically what a routing table or a forwarding table is. Sorry, yeah. So there is routing and forwarding also. And all of this is spoken about in the video, right? So I highly suggest that you go and look at the video. Now let's look at the questions, and let's quickly look at the questions. There are like 20 questions right now, I think. Ideally, from the next few weeks onwards, we can concentrate more on the questions and answer and explain theory as we look at the questions. But for today, I'll just be bluntly putting the answers out. So this is for your reference, right? Because this is our actual objective, to solve questions or to look at questions and answers, right? So and you feel free to answer these questions also. You can put it in chat, or you can uh, unmute and speak. So first question: which of the following operations are performed when packets enter the ingress interface? I just told you what ingress interface is. Any answers? I mean, for this, you should have seen the videos week 1. Without that, you won't be able to answer these questions. You can just put options A, B, C, D, or whatever it is, or you can unmute and speak. You can be completely wrong as well.
I think D is correct.
Okay. D is correct. Any other answers?
I think it is A.
Okay. So the answer is A. Correct. So the FIB. So this is what would have confused everybody. I think the forwarding information base. Correct. FIB. So it's nothing but a routing table. Assume it's a routing table. So a packet comes. So what do? You take the IP address, right? And then you check the table. And then what does this table give you? The output interface. So that's what it says. It consults the forwarding information base and determines the output interface. So the answer is A. Right? So the answer for the first one is A. You're able to see the questions, right? Are you able to see the questions? Oh, yes, I think, yeah, you are.
What is FIB?
Okay. Forwarding information base.
Okay.
So it's nothing but a forwarding table, uh, which actually it contains MAC addresses, but I don't want to confuse anybody right now. So it contains some address. Let's say so it's some address, and then for this address, where should I send it to? It's like you check a list of addresses. If this address is there, then I'm sending it to this particular port, or this particular port, or this particular port, so that it will reach that point. How it determines the table, how the table is built, all these things probably we'll be seeing it later. So that requires some algorithms. You would have studied some OSPF, BGP, sorry, OSPF, even BGP also, or yeah, some of these algorithms which creates these routing tables, right, in your basic computer networks course. Essentially, it does that, and then finally it is converted to an FIB. That's all. In the end, it's always going to be a table which is looked up, and then the output port is determined and it is sent. This is how every router works. That's what in the end a router does. Whatever algorithm you use on top, in the end it becomes a table in the bottom. That's it. Okay. Oh, yeah, quickly, like lots of questions to go through. So which of the following statements are true? Yeah, which of the following statements are true? Okay, I think just a little bit of context before this. So a router, as I was telling you, this has two planes: control plane and the data plane. Right. So ideally, I would want to explain what this uh, control plane and data plane are. But it's also explained in the videos. So if I go into this right now, we won't be able to look at all the questions. So I would like to prioritize the questions. And even if you don't understand the questions completely, just note down the answers. I'll clarify control plane, data plane operations and functions in the next class. Right, but there is one diagram I think in the second lecture. I'm just giving you the pointer as well. There is a diagram in the second lecture which talks about router components. Okay. There is a control plane and there is a forwarding plane. Just note this down. Second lecture, control plane and forwarding plane. It's nothing but data plane, right? And that will give you the necessary understanding about what happens at a router. But anyway, coming back to this, which of the following statements are true? Okay. Someone is saying A.
I think C.
A is false.
Control plane function are not performed on each arriving individual packet.
Yeah, C is true. It is not done for every packet, and B is also true. Right? A and D are false. Uh, yeah. So B and C are true. A and D are false. see the control plane. See, this is like the bigger brother. So this is determined once in a particular time frame. Let's say once in 1 minute or once in 2 minutes. So this is determined, and the FI and the table, right? The actual table or the FIB is present over here. Right? Every packet comes, it looks it up, and then it puts it onto the appropriate output interface. For every packet, a control plane functionality does not work out. A routing algorithm does not happen. Again, watch the videos. You will be able to get the answer. We'll be able to connect with the answers. But right now, I apologize. I'm just uh, giving you the correct answers, and I'm just going forward. You can try and link it if you watch the videos again, right? So B and C are correct here. So assume that an ISP has the following. Okay, this is classless interdomain routing. I mean, I can run through this, but I really want to explain to you what CIDR notation is and classful notation is. But we really don't have the time to do it right now. Okay, let me just breeze through the answers. The answer is A here, right? For those of you who already know this, it'll be easy. But for those of you who don't know, what I'm going to explain right now is not sufficient for you to understand the whole thing. I should go at it from the scratch. So again, what is this? This is an IP address. But I told you an IP address is like it's like 4 octets. What is this /19? Right? So this is an IP address, and then you put a slash, and then you put a number over here. Let's say 19. So this gives you how much of the IP address is the network address and how much of it is the host part of it. Now, when they say an ISP has the following range of CIDR based IP addresses available to it, right? So it says that 19 bits of this IP address is for the network. Right? I think we'll revisit the same questions again in the next week also. So that, I mean, this will probably take a whole hour for me to exactly explain what is CIDR, why did CIDR come up, and what is classful and why classful was replaced with CIDR. What is a network address? What is a host address? It's definitely the next 20 minutes is not enough, right? Which of the following is so
Sir,
yeah,
why it is
yeah,
saying following range of CIDR based IP address? I think this is a single IP address.
yeah, correct. This is a single IP address.
200.200.1280. Then
Correct,
why it
correct.
is
Okay,
saying following range?
correct. It is a range. I'll tell you why. So
Can we explain little bit, sir, rapidly?
yeah. It says 19, correct? So when it says 19, it means that the first 19 bits, correct? So what is this?
Our
This is like
network bit.
200. Yeah, first 19 are network bits. So what is 200 in binary? Can anyone just put it fast? I think I can explain it also right now. 1 second. 200 in binary. Okay, so this address, right? So this address is nothing but 1100 1000 yeah dot 1100 1000 dot 128 binary is 10000000 dot 0000000. Correct. And one more zero. Yeah. Right. So this is the IP address. Now your question was, why is it a range? Why are they calling it a range? Right? So what CIDR does is it says the first 19 bits of it is going to be network address. So what are the first 19 bits? This is 8, this is 16, 17, 18, 19. Correct. So we are putting we are cutting it over here. This is the network address part. Right. So with this as the network address part, this is going to remain constant. It's not going to change. But what is going to change? You have all of these bits. How many bits are remaining? 8, 9, 10, 13. 13 bits are remaining. So with 13 bits, how many IP addresses can you have? 2 to the power 13. Correct. Are you getting it? So it starts with
Yeah, right,
0,
sir.
0, 0, 2, and then it will start with 0 to this 2 to the power 13. So all the combinations of numbers here, right? You make this one, that will be another IP address. You make this one other IP address. That's why they call it a range of IP addresses right now. So in this network address, you have these many hosts, these many IP addresses are possible. That's what they mean actually. And that's why they call it as a range. Correct. So the ISP wants to give half of these addresses. So again, see how many addresses do you have right now? You basically have 2 to the power 13 addresses right now. Correct. How many do you have in your hands? Do you get this point till this point? 2 to the power 13
Yeah, yes,
IP
sir.
addresses we have. So हाथ में इतने हैं मतलब we have 2 to the power 13 and the ISP says that it wants to give half of these addresses, half of 2 to the power 13, right? Half of 2 to the power 13 to an organization called ABC. Okay, so half to ABC, quarter to XYZ, and then the rest itself. Correct. So essentially, you just have to allocate 2 to the power 13 by 2 to this, 2 to the power 13 by 4 addresses to this, and the rest of it over here. Now you can do it manually also. You can say, okay, 0000001, I'm giving it to organization ABC. 00002, I'm giving it to XYZ. You can do that also. But that is not the most efficient way of doing it. And the routers will have a very tough time. Their routing table will increase like crazy. So because of that, we have to do the allocation in a very systematic way. Correct. So out of these 2 to the power 13 addresses, half of it has to be given to organization A. So what is that? 2 to the power 13 by 2 is how much? It is basically 2 to the power 12 addresses. Correct.
Right.
And then quarter of it have to be given to organization XYZ. What is a quarter of it? 2 to the power 13 by 4, which is 2 to the power 11. These many addresses. Do you understand how this came? 2 to the power 13 by 4. Quarter is how much? By 4 is, well, this is 2 to the power 2, right?
Right, sir.
So this is 11. 2 to the power 11. And finally, the rest have to be given.
So the rest would also be 2 to the power 11, right? Because half, quarter, becomes
Exactly.
1, right?
Yeah. In this case, yes, it adds up. It adds up. Okay. Okay. So it's now we know how much to give. So now how will you divide this? Correct. Now it's very simple. So if you want to divide this space by half, which space? This space. Correct. This space by half, because this is what we have in our hands. Correct. How would you divide it by half? someone would say, okay, let's put a wedge here and divide it by half. No, but that's not the case. So I'm not writing anything in the network address part. Network address part remains the same. So this comes here, okay? But imagine if you put 1 here, okay? And then you put 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0, correct? So if this particular bit that you see here, if I change it to 1, correct? So this whole space and this whole space, correct, it becomes available host addresses, in the sense that you can partition the available host addresses by changing just one bit. All the addresses that start with the 0th bit here, and all the addresses that start with 1 bit here. Am I making myself clear, or is it not clear? I'm just curious. If you don't get it, then please call me out. Say I don't understand what you're saying. I don't understand a word you're saying. Right? So again, what
Understand.
you didn't understand, right? You could not understand,
Understanding, sir.
like you understanding. Fine. So why we're doing
Yeah,
this,
yeah,
we
yeah.
want to do we want to divide this by half. So you can divide this by half like this also. Like you can just put a wedge in between, or you can do it more intelligently, and then you can say everything that starts with 0, 0, this bit being 0, and everything that starts with this bit being 1. Correct. So now, if this starts with 0, correct, what will be the number that you can see here? It'll be 200 dot 128 dot 0. Yeah, it is. This is exactly like subnetting. This is pretty much subnetting only. Yeah, Sean Sosa here. Correct. But if it has a 1 here, correct, what will it be? What is 1001000? What is this in decimal? 100.
Yeah, 144, I guess.
Okay, in decimal. Yeah, I'm just verifying. I think I'll just take your word for it. Yeah, it's 144. So it's 200 dot 144, correct? Dot 0. Does this make sense? So if I put this bit as 1, so this third octet becomes 144. Right. So if this third bit becomes 144, that means half of the IP addresses are available for the ISP to assign, correct? So in the sense, if the ISP wants to assign addresses to an organization called ABC, right? ISP needs to take the first 19 bits from 200.200.128.0, okay, which is basically this, and fix the 20th bit, correct, which is the 20th bit. This is the 20th bit. You can fix the 20th bit as either a 0 or a 1, correct? So
Right,
you
sir.
have
I understood
you
whole
you you you,
concept.
you, you you got it. Yeah, so pretty much, in fact, you can do this in multiple ways. It's just one way is not the, you can do it in multiple ways also. You can say that you will give everything from 1, starting from 1 here to organization ABC. That's also fine. But among the answers that are given, if you calculate it like this, the answer is A, right? You can try this by yourself, but since there's literally no time, we're just moving forward. Okay.
Basically, it is. I think
Yeah,
basically it is giving subnet to these companies according to
that's all.
demand of number of hosts.
That's it. That's all it is. Nothing
Yeah,
else.
yeah.
Nothing but
Only
submitting.
thing, the
Okay, thank
second one I didn't get it. 200.200 128. Why did it start from 128? Anyway, I think in the next class we
Yeah,
can
yeah.
try
We
to
can
do
definitely
that.
look at it.
Yeah,
But why did it?
yeah.
Yeah, why did it start with 128? Wait, which one? XYZ, right? XYZ is one. Yeah, it starts with 128. But you have to see. I mean, in the answers, it is /21. So you go one more bit deeper, and then you partition it so that you can quarter it later, right? We can again. Ideally, I would have. Yeah, this is going to take time to explain now. So the answer to the blunt answer to your question is you should notice that there is a 21 here,
Mm.
which means you are going right now. It was 19, but then you are going one more bit deeper, and then you are saying this bit you will flip it to either 0 or 1, so that it'll quarter it. So basically among this network, which is basically half of the available addresses, you are halving it again. How are you halving it? By making it /21. But yeah, we'll see this in the next class, right?
Okay.
So yeah, what are the goals for designing core routers to meet increasing internet traffic? So core routers have to handle a lot of traffic. What are core routers? Core routers are those which are in the internet backbone, which basically see Gbps of data. So what are the three things that they need? They need a very good packet forwarding performance, and then they need scalability as well. Scalability is that it needs to be able to scale to a large number of packets. Scale is like you increase the number, scaling to something more. And D is it needs to be available in the sense you it can't die randomly. It needs to have availability also. So these are the three things. And modular degradation doesn't even make sense. It's not even a word. So you can easily just take the other ones here. And what are the components of line cards? So if you see the lecture, so it is the CPU, the very same second lecture. If you see it, there is the CPU and the transponder and the network processor, right? So it's number 5. I'll put this document out so that you can look at the answers. Number 6, what is the role of router architecture's forwarding engine? So again, there is the control plane and then there is the forwarding plane or the data plane. So what is the role of it? It needs to process the packet headers and check the IP address and match the IP address and send it. So how does it do it? First, it needs to look at the packet header. Packet header is basically your layers that we just spoke about. Okay. And which of the following IP prefixes correspond to a class B address? Oh, so this is class full addressing. We so far, the previous question that we were solving, we are looking at classless. So this is classful. Classful is obsolete. It is not used anymore. This is just for question answering purposes. This is explained in the video also. So the answer is A and C. Right. So yeah, let's not go into this right now. Okay. I'm just giving you the raw answers right now. That's all. So a network with IP address this, how many bits represent the host in this IP prefix? So how many? This is just easily answerable. So how many bits represent the host in this IP prefix? Can anybody answer?
4 bit.
4. Yeah, good.
Yeah,
So
Okay.
right, Sean. Yeah, Sean and Anuradha. Dhruv. Yeah, great. It's 4 bits. Ninth one is okay. This is Tier 1 ISP. I think in the very first lecture this was given. So it's, I mean, it's just directly from the lecture. Not sure if these kind of questions will be
Yes,
asked in
yes.
your exam.
I think AT&T.
Yeah, it's like there is AT&T, there is Verizon, and there is Telstra also. It seems these are all the Tier 1 ISPs. And Act FiberNet, I think, is in Hyderabad. I think this is an Indian one. These are all American. So, yeah, this is a direct question from the theory, basically. So, and what are Tier 1 ISPs? It's explained in the video. Again, there are different types of ISPs and ISP routing, border routing, all these things. But it's very difficult to explain all of that in one class. So let's look at it when we come to the particular context of the next classes. Okay, a small organization with 60 employees that use Class C networks. How many IP addresses are the organization wasting? Okay, this is an interesting question. So, Class C address, right? So Class C networks, they basically have how many hosts? They have 254.
256.
Oh, okay, 256.
Yeah, right.
254. So if you minus 60 from it,
It will be 192.
194.
So
Right? 194. Now, why did I do this? Again, Class A, Class B, Class C. So Class A would have how many host addresses? I think 2 to the power 24. 24 minus 2. This is 2 to the power 16 minus 2. This is 2 to the power 8 minus 2. Correct? This is just, if you just go and look at Class A, Class B, Class C in the video, you'll understand. It's nothing, not a big deal at all. So from this number, right, they said Class C. Class C has how much? It has this much. What is this equal to? This is equal to 254. And how many do they need? They need 60. So if you only use 60 from 254, you will have 194 remaining, which is unused. But sadly, the whole network address has to be assigned to this organization. That's why it's being wasted. Correct? Okay.
Won't you reserved one for network and for sub? There are two which are reserved, right? Out of the
Yeah, there are two which are reserved. Yeah, broadcast and
yes,
network.
broadcast and network. Yeah.
Yeah. 000 is for.
Sir, in the question, it is not mentioned that
Mhm.
if we have to exclude the broadcast and the network address, so how will we answer in the exam, sir?
So, I mean, you have to include it. I mean, you cannot exclude it. You're looking at real life right now. Why would you exclude it? Like, unless and until they tell you, don't worry about the broadcast and network addresses, you have to include it. Got it?
So in
I
question,
think we
then
have to
the
mark.
correct answer would be 196, no?
You're saying 196 because you are saying 256 minus 60, right?
Yes, sir. Because in the question, it is not mentioned to remove that the broadcast address and the network address. Because this mistakes can be happen in the exam too.
I think probably in the exam they'll explain it, but take it as a rule of thumb. Always include network and broadcast addresses. Okay. I mean, that's pretty much how it is. But yeah, again, you can get confused. You can also say 196 also. But yeah, because we're talking about classful addressing, this which is already hypothetical. I think it's not fair. I think they should answer. I mean, they should definitely give you the meaning of whether you have to add these network addresses or not. But yeah, as of now, keep this in your mind. Oh, have broadcast addresses. I mean, just keep it in your. Include them and use it. So see,
Okay, sir.
this is a reserved for network and broadcast. I think it's always reserved 000, whether it's classless or classful. Two IP addresses are always reserved for broadcast and thing. So always include it. Yeah, that's final thing. Always include it. Okay. Now we have 3 minutes. Okay, fine. Again. Okay. How many usable host IP addresses are there in a class B network? The subnet mask of so and so and so and so. The answer is D. Subnet mask is something that's equivalent to the slash notation that we saw. Again, okay, I'll just give you the answers. We'll look at some of these. If you have questions in the next class and some of these questions, we'll take a look at it again, right? Which routing plane is responsible for exchanging routing information with neighbor routers? So it is the control plane, in the sense that if you want to figure out where to send the packet to, that is being done by the control plane, and then it is put into the forwarding table. Again, I'll explain this properly in the next class. I don't have time right now. And which of the following statements are false? Control plane operation involves routing table construction. Yes, this is true. The data path operation is a routing table construction. No, it doesn't have. It does not have anything to do with routing table construction. It just has to do with reading the packet header information, comparing it to the forwarding information base, and then sending it on to the output. So this is false. Control plane functions are performed on each arriving individual packet. No, this is also false. Okay, we saw a similar question. Data path functions like output link, scheduling, and forwarding relation are not performed on every datagram that passes through the router. Um, the data path functions like output link, scheduling, and forwarding are not performed every datagram that passes through the router. This is also false. So false, 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 right? Okay. And 4. A network with IP address so and so, how many bits represent the host in this IP prefix? How many? Quickly. 8. Good.
32 minus 24. It will be 8.
Yeah, 8. Correct. Perfect. Yeah, Aryan and Sean. Which of the following is not a component commonly found in line cards? It's the router controller, in the sense it's the control plane where you have a controller for the router itself, but there's a completely different concept. We watch the video, and if you have still questions on this, let's discuss in the next class. Right. So I think from next class we should directly go into the questions, because we don't have enough time to talk about the theory as well as go into the questions. What is the primary function of switch fabric in a network switch? A switch fabric is not. It's not a cloth. It's the switching functionality in a chip. It looks like a fabric because it's like it connects. Let's say 1, 2, 3, 4 to 1, 2, 3, 4. It's like it goes like this. It connects all of these input to the output. It looks like a fabric. That's why they call it a switch fabric. What it's supposed to do? It has to forward data between input and output ports. That's all. So what is the role of an arbitrator in the context of packet arbitration in the switch? So basically, this comes into the picture when you have contention with packets, when you have to make a choice based on the current load on that particular output port. These are some nuances, but essentially it's to solve the output contention, meaning there are many output ports. Which output port do you want to put it onto, and you have to wait for putting it on the output port based on the current conditions. If the particular output port's queue is a bit large, it already has so many packets to go through, probably you can put it into the other output port as well. So these decisions that are taken, right, that is done by the packet arbitration aspect. It's nothing but it's slightly advanced. It's not just directly looking into the table and putting it on the output port. It's slightly more than that. But essentially, the answer to this is A. What is a specific task performed during egress operations in packet forwarding? Okay. Yeah, so packet forwarding happens in the second part. Okay, so this is data plane, control plane, and consult FIB and determine the output interface. checksum calculation, add link layer header, or is it to determine TTL, decrementing TTL? No. Okay, let's look at this question in the next class. I think I don't agree with the answer given here, but yeah, we'll get back to this. As a network administrator, your task is to assign IP addresses to hosts in the subnet. Yeah, very similar question that we try to solve. Try solving this question in your free time this time, right? And the answer is
A and B, I think.
B and C, right?
Yeah, right, right. C,
It's
right.
it's
A
B
will be
and C,
network address, right? Right, right. B and
right?
C.
Yeah, yeah. Okay, I think you've pretty much figured out fast. Okay, so I think from the next class onwards, probably I'll directly jump into the questions. Yep, and that's pretty much it. If you have any questions, you can ask, or we can just end the meeting and we can move forward. Yeah, thank you. And one more thing, it'll be great if you can watch the videos and come for the classes so that we can have better discussions, right? Okay. You guys can leave. Bye-bye. See ya.
Okay, bye, sir. Nice class. Thank you.
Bye-bye. See ya. Bye. Bye, Mahesh.